All right, so we're now moving on to the next section of this chapter, section 20D, and this is going to have two videos. So this is going to be the first video that we're doing in this section. And we're now going to move on to similar triangles. All right, so you'll see this is very similar to what we were doing before with congruent triangles, but there's one major difference. And we're going to talk about that in detail. All right, but our objective is to understand what similar triangles mean and to be able to identify if triangles are similar or not. Right? That's going to be the first video. The second video is sort of what we did in the beginning as well with section 20A, where we talked about congruent triangles, and then we were applying to solve for missing sides and angles of congruent triangles. It will be the exact same thing for this as well. All right, so we're just going to first be able to identify what does it mean to be similar, and also how to identify if they're similar or not. And then our next video, we will go through solving problems. All right, so remember, we just got done talking about congruent triangles. And we know that congruent triangles mean that they are the same in every way. They're the same shape, and they're the exact same size. So we would say that these two sides are congruent to each other, these two, these three. And then we also knew that that meant that these angles in between were also congruent as well. And we can go ahead and list all these. Because when we were congruent, we were the same in every single way. Right now, when we are talking about similar triangles, right? Similar triangles are triangles that have the same shape, but not the same size. So one is either smaller or larger than the other, right? But if you notice, these two triangles here, they look like they're the exact same shape to me, like they are very similar. But you notice that these are not the same sides. This 3 became a 6, this 4 became an 8, and this 5 became a 10. Right? So the difference is congruent triangles, they had to be congruent in every single way. We had all these tick marks, all these arc marks, and everything had to be the same. In similar triangles, they don't have to necessarily be the same exact size, but they must be the same shape, but not the same size. All right? And we're going to go through now in more detail how to determine, are these actually similar or are they not? Right? And there will be 3 methods that we go through in this video. All right, so the first one that we will discuss is that we know two triangles are similar if they're equal angular. And what does that mean? That they have all corresponding angles are congruent. Right? So if I draw these two triangles, and I tell you that this is equal to 60 degrees, this is equal to 60 degrees, that this is equal to 50 degrees, that this is equal to 50 degrees, and then that this one is equal to 70 degrees, and so is this one. So the first way we can tell that they are all or that these are similar is we can look and see, due to corresponding angles, are they congruent? Well, these two are congruent, these two are congruent, and these are congruent. So we have 3 congruent angles, 1 arc mark with 1, 2 arc marks with 2, and 3 arc marks with 3. So since we have 3 congruent angles, we can then say without a shadow of a doubt that they are similar. All right, you can write AAA, which if you recall, I told you while we were doing congruent triangles, some of you kept wanting to write AAA, and I said that's actually going to come up soon. So that's the way that we can label this one. Now we're actually going to, let me just erase this. We're going to just talk about something briefly, because instead of having to show that all 3 angles are congruent, we can actually get away with just showing that 2 of them are. Because let's just say that I draw these 2 triangles, and let's say that I said that this is 40 degrees, that this is 70 degrees, that this is 40 degrees, and that this is 70 degrees. All right? And if we know, okay, well, we have these 2 congruent triangles or congruent angles, it's guaranteed that the third are congruent as well. All right? Because in both of these cases, we know that these triangles add up to 180 degrees. So regardless if we're solving for this missing angle in this one or this one, we're still doing 40 plus 70, and we'd still get 110. And 110 because they're the same. And then in both these cases, we would subtract this from 180. And in both of these cases, we would get 70 degrees. So that means this missing angle in both of them has to be the same. So we can either show that all 3 angles are the same, or as a shortcut, if you just show me that 2 are the same, it's guaranteed that the third one has to be congruent as well. And that's through our third angles theorem. All right, so you can either show me that all 3 are congruent, or based on the problem I give you, if I show you that 2 of the angles are congruent, we know 100% yes, they're similar. All right, so that is one of the methods, either AAA or AA, whatever you want to put. All right, then the next way that we can tell that they are similar is triangles are similar if their side lengths are in the same ratio. All right, so if their side lengths are all in the same ratio, that means that they're similar. Now, what does that mean? Well, do you know what a ratio is? If I say that we have 2 apples for every 4 oranges, well, we can create a ratio of 2/4, and then this reduces to 1/2. If I say we have 3 apples for every 6 oranges, we can create a ratio of 3/6, and it reduces to 1/2. So although these ratios look like they're different, they're actually the same because they both simplify to give me the same fraction. And remember, a ratio is something I know you learned in detail in 7th grade and in 6th grade probably as well. And ratios are comparing 2 different things together as a fraction. So we can write it in different ways as well, but we're going to always write ours as a fraction. So 2/4, 2 apples for 4 oranges, and then we are always going to reduce our fractions. So let's write that first problem I had in the very beginning. All right, we had that this was 3, this was 4, this was 5, and then we had 6, 8, and 10. Right? I believe it was A, B, C, and D, E, F. Right? So now when we have these triangles, what you need to do is you need to decide which triangle you want to compare from and to. So I'm going to go from the smaller one to the larger one. So it's important that you have to stay consistent while you do this. So now I'm going to figure out what sides correspond. Well, if you notice, 3 is the smallest side of this triangle, so it has to correspond with 6 because it's also the smallest side. So we would then create the ratio 3/6, and that is equal to 1/2. Right? 4 is the medium size number, so one in the middle, and 8 is the one that's in the middle as well. So that means they must correspond. So I will create the fraction 4/8. So what I meant was you have to stay consistent. You can't do 8/4 in this case because we started by putting the smaller triangle on the numerator first and the larger triangle on the denominator first. So that means in every single one that we do from this point out, we need to stay in the exact same way. So we will then write 4/8, and 4/8 reduces to 1/2. So now we look and see, well, yes, these two so far are the same ratio. Then 5 and 10 are both the largest numbers, so we will then write our ratio with them, and that also reduces to 1/2. So if you see, all of these ratios are exactly the same. So since all of our side lengths have the same ratio, that means that these are similar, guaranteed. Right? And we could have did the same thing in reverse. We could have went with the larger triangle to the bigger or to the smaller one. We could have did 6/3, which is equal to 2/1. We could have did 8/4, which is also equal to 2/1. And we could have did 10/5, which is also equal to 2/1. So it doesn't matter which one you're going to do. It just matters which one you start, whichever one you start with first. You need to do that continually throughout. Right? In the second video, we will talk about when we're solving problems that it is actually important the way that you do this as well. And we'll talk about that in a moment. All right. Now, there's one more that you need to know. Right, then the last one that we're going to cover is 2 triangles are similar if 2 corresponding sides have the same ratio. So it's very similar to what we were just doing the last one, but instead of all 3 sides, because sometimes I won't give you all 3 side numbers, if I give you 2 corresponding sides that have the same ratio and the included angle is congruent, meaning the angle that is between them, then that means that we can say that they're similar. It's similar to the side angle side, but instead of the sides being congruent, they will have the same ratio. Right? And we can label this as SAS. So if we look here, well, this tells me that it's 90 degrees and 90 degrees. So I know that these are congruent. So then I will look and see, well, this is 4 and it's larger than 3. So 8 is larger than 6. So they have to correspond. And 4/8 we know reduced to 1/2. 3 was a smaller number, so it has to correspond to smaller. 3/6. Remember, I have to be consistent. I started with my smaller triangle on top first, so it needs to be on top again. So since these two both have the same ratio and the angle is included with them, we can say yes, that they are similar through side angle side. All right, so you'll see it's very similar in the ones that we've been doing so far. We have an SSS, we have an SAS, but now we're just doing an AAA or AA with it as well. We're not going to go through any of the other ones. These are the only 3 that we're going to focus on this year and this term. Next year, you will learn a few more, though. All right, now, just like with congruency statements, we do have a similarity statement that we can write and that you will need to know how to read as well. All right, so let me just add these angles in here just so that way we can talk about this in both cases. All right, we already know that these two triangles are similar because we already went through and did this where we're talking about the ratios. So just like before, it doesn't matter which one you do first. So let's just say that we're going to start with triangle ABC. So just like with the congruency statement, we will write triangle ABC. The difference is, in a congruency statement, we wrote this symbol over top of equal. Well, in a similarity statement, it is just this symbol. So we just write this. That is it. We do not write the equal underneath. That tells us that they're similar. And then we can go ahead and we can write the next one, and it needs to correspond. So D corresponded with A, so this would then be written first. E corresponded with B, it gets written second, and F corresponds with C, it gets written third. So just like with the congruency statement, but now this says that they're similar. And one of the things that we need to know from this is it's not that AB is equal to DE. We then would write AB over DE, because when we're talking about similarity, we're creating ratios. And then it's equal to BC over EF, because that's our ratio because they're in the same spot, which is also equal to AC over DF, right? So you see it's slightly different when we talk about the sides now. It's not that they are equal because they're in the same spot. It's the spots that are, the things are in the same position that are corresponding. They create a ratio that is equal to all the other ratios that are corresponding as well. All right, that's the only different that you need to know. All right, now we're just going to go through and answer a couple questions of each type.